Bismillahirrahmanirrahim. Assalamu alaikum students. Last time we gave introduction. We started our syllabus. We started, in fact, the first unit of our syllabus. The name of your course is mechanics. In last lecture, I introduced you to mechanics, right? And at the end of the lecture, I said that physical quantities, physical quantities we classify broadly into two groups. One was scalars, second was vectors. We said scalars have are specified by magnitude only, vectors are specified by magnitude and direction. Then we gave certain examples and we said that scalars can be handled by using ordinary rules of algebra. They can be added, subtracted like numbers, but due to the involvement of direction in vectors, there is involvement of geometry. We cannot add, subtract vectors using ordinary rules of algebra. There are separate rules for handling vectors. Those things we have to discuss, right? First thing, how we represent vectors, right? So we represent vectors graphically. I write here graphical representation of vectors. You know this. I'm just revising it. Graphical representation of vectors. How we represent graphically vectors? We represent a vector graphically by an arrow, right? By an arrow with the condition that length of the arrow is proportional to the magnitude of the vector. Magnitude of the vector. Second thing, direction of the vector is indicated by the arrowhead. You have to remember this, that when we represent graphically any kind of vector by an arrow, we have to keep these two things in consideration, that length of the arrow is proportional to the magnitude of the vector and direction of the vector is indicated by the arrowhead. I will explain this. Suppose I have to represent three vectors. One vector is A, it is 3 Newton along east. Another vector is B, it is 6 Newton along west. There is another vector C, which is 9 Newton along northeast. Now from SI unit, you can easily understand all these three vectors are representing force. They're force vectors. Why? Because their magnitude is expressed in newtons. Newton is the SI unit of force. So one is having a magnitude 3 Newton and it is pointing along east. So this is 3 Newton is its magnitude. Along east is its direction. 6 Newton is another vector along west. 9 Newton is the magnitude of C, another force vector along northeast. Now suppose we are given these three vectors and we are asked graphically represent these vectors, right? We proceed like this. Let this be my north, and this is south, this is east, and this is west direction, right? Now I have to graphically represent these three vectors. So I have to select my scale. So let 1 centimeter represents 1 Newton force. And I have to draw vector A whose magnitude is 3 Newton equal to 3 centimeter, but along east. So my A will be like this. Along east, and its magnitude, its length will be how much? 3 centimeter. Now when I do this graphically, I have to measure it by scale. I'm showing it, illustrating it how we do it, right? You have to exactly measure its length equal to 3 centimeter, because 1 centimeter is equal to 1 Newton. I'm taking that scale, right? Then I have 6 Newton along west. So B vector will be double its length. This will be B vector, and this length will be 6 centimeter. You have to ensure its length to be 6 centimeter. 6 centimeter will indicate 6 Newton, right? Then I have 9 Newton along northeast. Northeast means the direction which bisects this. You have to make here 45-degree angle. This is the meaning of northeast, right? So my another vector C will be along northeast, and its length will be how much? 9 centimeter. This will be my C. This is how we graphically represent vectors. Now it is immaterial whether I draw this A here, 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 or anywhere in the plane. But I have to keep this thing in mind, that its length be 3 centimeter and along east and directed along east. Same is true with B. You can draw it anywhere. You can draw C anywhere, keeping its length 9 centimeter and pointing its arrow along northeast. This is how we represent graphically vectors, right? Now C, you can see from the figure, since the magnitude of C is 3 times the magnitude of A, so when we represent graphically these vectors, length of C will be thrice compute A. Since B is having twice magnitude as A, so length of arrow indicating B will be twice as A. Now, when we select this scale, it's our choice. We could have taken another scale. For example, if someone says, let 0.5 centimeter be 1 Newton, it's okay. Then he has to make the length of A called 0.5 is 1 Newton, then for 3 Newton, it will be 1.5 centimeter, right? And it will be 1.5 twice, that is 3 centimeter. It will be 4.5 centimeter, right? If 0.5 centimeter represents 1 Newton, right? So you can have any scale, but once you fix a scale, you have to use for all the concerned vectors in the problem. So whether you use this scale or this scale, one thing will be true, that the arrow representing B will have double length compared to A, and the arrow representing C will have triple length compared to A. This is the meaning of this thing, that length of the arrow is proportional to magnitude of the vector. Direction of the vector is indicated by the arrowhead. So now you know how to represent vectors graphically. Now we move forward. So next thing is properties of vectors, right? So first thing is equality. You know this from your previous classes. What is when two vectors are said to be equal? So two vectors are said to be equal when their magnitudes are equal and they are similarly directed. That means if I say vector A is equal to vector B, that means magnitude of A is equal to magnitude of B. This is the notation. When I place it in mod, that means it's length only, magnitude only. So if A is equal to B, that means magnitude of A is same as magnitude of B, and A and B are similarly directed, right? So when two vectors have same magnitude and they are similarly directed, they are said to be equal, right? Second thing is negative of a vector. Negative of a vector. What is the meaning of negative of a vector? If A is some vector, which vector is minus A, right? So if A is some vector represented by this arrow, we have a rule that minus A is a vector which has same magnitude as that of A, but is oppositely directed to A, right? If A is some vector, minus A is a vector which has same magnitude as A, but is oppositely directed to A. So A is negative vector of minus A is negative vector of A, right? Then we move forward. Third thing. triangle of vector addition. Triangle law vector addition. So if I have vector A and vector B, I have to find the result and I have to add them to have a law is called the triangle law of vector addition. It says if you have two vectors A and B, in order to find their resultant, the vector which represents A plus B, what you do, you place the tail of B on the tip of A, then the vector, I will use different color, then the vector pointing from the tail of A to the tip of B, this vector represents A plus B. This is called triangle of vector addition, right? So this is simple. In order to add two vectors, represent them graphically, place the tail of second vector on the tip of first, then the vector emerging from tail of first to the tip of second is their sum. Since the diagram is triangle, we call it triangle law of vector addition. Sometimes this A plus B is called resultant of A and B. Got it? So we have another thing. I have space here. Parallelogram. Parallelogram. Law of vector addition. You know what is parallelogram? Parallelogram is a quadrilateral four-sided figure whose opposite sides are parallel and equal in length, right? Now, this parallelogram law of vector addition is also used to find the resultant of two vectors. It says if you have two vectors, for example, your vector A and your vector B, right? And you want to add them, you want to find the resultant of them. That means you want to find A plus B. What do you do in parallelogram law of vector addition? You join their tails. You join their tails. And what do? You complete the parallelogram. So we complete the parallelogram. That means I will make one side equal to B and parallel to B, and another side equal to A and parallel to A. And what I do, the diagonal of this parallelogram emerging from the vertex where A and B join, where the tails of A and B join, represents my A plus B. This parallelogram law of vector addition. What does it say? If you have two vectors, you want to find their resultant, you join their tails, complete the parallelogram, then the diagonal of this parallelogram emerging from the vertex where the tails of A and B join represents your resultant A plus B, right? So it's actually triangle law. It's actually triangle law, but we are using here equality. See, we said two vectors are equal when they are similarly directed and equal in length. So since this is parallelogram, this side is also B. This also B. And this side is also A. This also A. So actually I am placing at the tip of A the tail of B. So from triangular it's my A plus B. Or I'm placing the tail of A on the tip of B. So I'm getting B plus A. Got it? So it is simply triangle law using equality of vectors. So you can use triangle law, you can use parallelogram law of vector addition to find the sum of two vectors. Here you join tail and tip, here you join the tails, then complete the parallelogram as I have explained to you. So here is one more property, vector addition is commutative. Commutative. Law of, when we say addition is commutative, for example, in numbers, 2 plus 1 is same as 1 plus 2. 1 plus 2, so both are 3. Or in general, A plus B is same as B plus A. Same is this called, when this thing happens, when order of addition doesn't affect the result, we say addition is commutative. Same is true with vector addition. If I have two vectors, A plus B is same as B plus A. So whether you add B to A or A to B, you get the same vector as your result, as is indicated in the previous diagram, this diagram. I draw it once again for you. So I have A, I have B, right? We complete the parallelogram. If this is B, this is also B, this is A, this is also A. So my resultant is this C. My resultant is, if I use these two, then this is my resultant, A plus B. Now you see, this is A, and on the tip of A there is B, so this vector is A plus B, right? Now see on this side, I'm placing the tail of A on the tip of B, so this is also B plus A, according to triangle. So A plus B is same as B plus A. Whether you add B with A or A with B, you are going to get the same result. Vector addition is commutative. Then we have next thing, vector addition is associative. In the law of association, there is involvement of 3 elements. You must be knowing this. For example, in numbers, A plus B plus C is same as A plus B plus C. When this thing occurs, we say addition is associative. See, operation wise, left hand side and right hand side are different things, but they are equal in case of numbers and also in case of vectors. Here you are adding first A plus B and then you are adding the result with C. In right hand side, you are adding B with C, then the result is added with A. Same is true with vectors. A plus B plus C is same as A plus B plus C. We have three vectors. We will show it that through diagram that they are equal. First I find left hand side. So this is my A, let this be my B, and let this be my C, right? So I have three vectors. First I find left hand side. So according to triangle law, this vector is my A plus B. Then I have to add that to C. So tail of C is on the tip of A plus B. So this vector is A plus B plus C. A plus B plus C. Now C, the right hand side, is the vector of my left hand side. Now move to right hand side. Add first B with C. This is B, this is C. I'll use a different color. So this is my B plus C. Because on the tip of B, I place a tail of C. So this is my B plus C. And I have to add that to A. C. This is A. On the tip of A, I have B plus C's tail. So this vector is the resultant. So it's also A plus B plus C, right? A plus B plus C. This also A plus B plus C. So this is the same vector. That means vector addition is associative, right? Then we have, this was our sixth property. So what we have done, let me check. Equality we have done, negative of a vector we have done, triangle law of vector addition we have done, parallelogram law of vector we have done, vector addition is commutative we have done, vector addition is associative we have done. Now another thing, subtraction of vectors. This is my seventh or sixth, seventh. Subtraction of vectors. Subtraction of vectors. Suppose if I have to subtract vector B from vector A, how we do that? We add to A the negative of B, because A minus B is same as A plus minus B. So to get the vector, this vector, to subtract B from A, we add minus B to A. I will show you with diagram. So this is my A, this is my B. If I have to find A plus B, you know this is A plus B, right? Using triangle of vector addition. But if I have to find A minus B, this A plus B, first find minus B. This is my minus B. because minus b will be negative of b, that will have same magnitude as b but oppositely directed. Then I find the resultant of a and minus b. I add minus b to a. So from triangle of vector addition, from the tail of a to the tip of minus b is a plus minus b, which is same as a minus b. Got it? So if I a, this was b, this is a plus b. To get a minus b, I first find minus b. Then I add minus b to a using triangle law. That is a plus minus b, a minus b. This is how we subtract vectors. We have another thing. I have space here. We define a vector called zero vector, or we call it null vector, right? What is its definition? A vector with zero magnitude. When it has zero magnitude, there is no question of direction. Because when vector has length, only then you say which way it is pointing. If it has no length, there is no question of direction. Now, why we define zero vector or null vector? It is useful. For example, if you are asked if I add minus a to a, what I get? I get a zero vector, right? So if, and similarly, which vector I add to a in order to get a back, that is zero vector. So if you add zero vector to any vector, you will get that vector back. And if you add a vector with its negative vector, you will get a zero vector, right? So zero vector is like zero in numbers. In numbers, you know, if you have some number 1, you add 0 to it, so you get this number back. And uh, negative is here additive inverse. For example, if I add 1 with minus 1 is called additive inverse of 1, you get 0. Here you have negative vector, you have additive inverse. Here you have 0, here you have 0 vector, right? Similarly, we define another thing that's called unit vector. Unit vector is, by definition, I write it a vector with unit magnitude and dimensionless. So unit vector is a vector which has magnitude equal to 1 and which has no dimensions, which has no units, right? And we have a separate notation for unit vector. If I write A, then I keep arrow on it, it is a vector. But if I write A and I write hat on it, then it's a unit vector, right? So when you put hat on A or any symbol R cap or R hat, it's notation of a unit vector. If you place this arrow, or in print we write in bold, right? Then that is a vector. Cap indicates a unit vector, right? Then we have, can we do it here? Then we have multiplication of a vector by a scalar. Multiplication of a vector by a scalar. Suppose I have vector A, or I multiply half to A. Now question is, what is half A? Or what is minus half A? The rule is half A is a vector with half the magnitude of A but same direction as A. And minus half A is a vector similarly directed as A but half the magnitude of A. Right? So rule is, if you multiply a vector by scalar, right, resultant quantity is vector in the same direction if that scalar is positive, and the magnitude of that vector is scaled by the scalar. That means magnitude gets multiplied by that scalar. And if you are multiplying vector by a negative scalar, resultant quantity is vector in opposite direction, but the magnitude of resultant vector is multiplied, scaled by that magnitude of that scale, right? Now there are other types of scalars. One scalars are these numbers. They have no units. There are scalar quantities also, like time. For example, if I multiply velocity by time, I'm also multiplying vector by scalar. Now, since it's a positive scalar times a vector yields a vector in the same direction, which is a rule. That means dv will be similarly directed as v. And the magnitude of this vector will be magnitude of t into magnitude of v. Similarly, if I multiply acceleration vector by mass, mass is a positive scalar times a vector yields a vector in the same direction. So ma is a vector similarly directed as a, right? And direction is similarly directed as a, magnitude of this ma will be magnitude of a into magnitude of m. So same as in numbers. So rule here is same. When you multiply vector by a positive scalar, resultant quantity is vector in the same direction and it is scaled by that scalar. You have to multiply the magnitude of the vector by the number. Same is here. But what is the difference? Here these numbers have no units. So if A is some vector, half A is same vector. Same vector in the sense that it has same units. Nature of the vector doesn't change. If A is force, half A is also force. If A is velocity, half A is also velocity. If A is acceleration, half A is also acceleration. But here, the nature of the vector changes. V is velocity. So it has units of meter per second. Time has units of second. Second gets cancelled. So Vt is not velocity vector. It is displacement, right? Similarly, when you multiply acceleration vector by mass, acceleration has units of meter per second square. Mass is kg, so it becomes kg meter per second square. That is Newton, so it becomes force. That's force. Got it? So in case of numbers, nature of the vector doesn't change. But when I multiply a vector by those scalars which have units, nature of the vector gets changed, right? So we have discussed, let me check if I have to tell you more about properties of vectors. Equality we have done, negative of a vector we have done, triangle law, parallelogram law, vector addition. Vector addition is commutative, vector addition is associative, subtraction of vectors, zero vector, null vector, unit vector, multiplication of a vector by a scalar. So these are the properties of vectors. Now, one more thing I will tell you. We know now unit vector has a spatial notation. We know a space, let this be x direction, this y is three-dimensional, and this is z. Now we have reserved three symbols for three spatial unit vectors. Three spatial unit vectors. One is I cap. I cap is a symbol for unit vector along positive x direction, right? Then there is another symbol j cap. J cap is a symbol for unit vector along positive y direction. Remember this, unit vector along positive x direction is I cap. Unit vector along positive y direction is j cap. That means another color. And k cap is the unit vector along positive z direction. Vector along positive z direction. Can you tell me what's minus I cap? Yeah, you can answer it. It is by the property of vectors unit vector along negative x direction. Because when we multiply vector by minus, it reverses its direction. And similarly, minus j cap will be unit vector along negative y direction, and minus k cap will be unit vector along negative z direction, right? Now I will give you some homework. Do your homework. So it is simple. So my question goes like this. A woman walks 250 meters in the direction 35 degrees east of north. Then 170 meters directly east. Part A. Using graphical methods. Using graphical methods. Find her final displacement from the starting point. From the starting point. Then I have second part of the question. This color. Second part B says compare the magnitude of a displacement with the distance she walked. I repeat the question. A woman walks 250 meters in the direction 35 east of north, then 170 meters directly east. Part A says using graphical methods, find her final displacement from the starting point. Part B says compare the magnitude of her displacement with the distance she walked. Solve this question. This all for today. Thank you. Be sincere with your studies. Do your homework. God bless you. Assalamu alaikum.